Hello students, in response to a query generated from an overseas student, I am doing this video. This video concerns the peptide sequencing of a given pentapeptide from its tandem mass spectra. Okay, so this is the question at hand. You're given this pentapeptide and it's fragmented into 5 different fragments. Okay, in the mass spectrometer. Okay, that's what happens in the mass spectrometer. The molecules get fragmented. The fragment 1 is 579.8 Daltons molar mass. Fragment 2 448.5. Fragment 3 347.4, fragment 4 218.3, and fragment 5 71.1. Okay, based on this, we need to find the sequence of this pentapeptide, its overall charge at pH 11, okay, as well as the isoelectric point. But first, we look at the sequencing, for which we need to know the fragmentation pattern in the mass spectra. Okay, this peptide has 5 fragments, and the N terminal has a tag or a cap, okay, which they do to protect the N terminal amino group from any unwanted reactions. Okay. So that tag will also have its own mass. We have to remember that. But let us first depict the pentapeptide. We can see there's a tag at the molecular tag at the N terminal, followed by the first amino acid, second amino acid. They're all linked by the peptide bonds, amide bonds. Okay. Third amino acid, 4 and 5. So A1, A2, A3, A4, A5 are the 5 constant amino acids of the pentapeptide from N terminal to C terminal. Okay. So the fragmentation will happen at the amide bonds. Okay. Can happen between the first and second, or can happen between second and third, third and fourth, fourth and fifth, and also can happen at the terminal COOH bond. Okay, so these are the places where the fragmentation can happen. And what happens is you get an acylonium ion, which is detected by that acylonium ion is pretty stable by resonance, so that is detected by the mass spectrometer. Okay, so these are the fragmentation points. You can see I have indicated them with the black vertical lines. Okay, so these are the various fractions: F1, F2, F3, F4, F5. So the 5 fragments and the respective masses are given as follows from the data. Okay, first fragment, okay, the cleavage is happening between the first and the second amino acid, the peptide bond, and you get this fragment F1 with a molar mass of 71.1. The second one is an F2 that is cleaved between the second and third amino acid, and you get 218.3, okay, the molar mass. So like that you see for all the 5 fragments. Okay, all right. So we can also see that each fragment is one acyl fragment heavier, okay, one acyl part or one acyl moiety heavier than the previous one. Okay, so mass of, and one more thing to notice is that when we are adding more and more acyl part, okay, to each fragment, we have to note that each acyl part of the adding amino acid is 18 less than the actual molar mass of the amino acid. Okay, because how do you make the acyl part? You are removing one hydrogen from its amino group, and you are removing one OH hydroxyl group from its carboxyl group, and so the total loss is 18. So that's why when you are adding the acyl part, you're going to get the molar mass minus 18. So that's what you're adding there. Okay, so let's first look at the lightest fragment F1. So F1 is a combo of both the amino tag, which has got its own mass, and plus the A1 amino acid acyl part. Okay, now the mass of the total mass of F1 is 71.1, meaning, okay, the acyl part of this amino acid should be less than 71.1, right? Because the tag is going to have its own molar mass. We don't know how much it is, but it's going to have a molar mass. So the closest match, in fact, the one and only match will be glycine, because it's the only amino acid whose acyl fragment has a weight of less than 71. Okay. So the next lightest amino acid, alanine, has an acyl part of 71. But then if you have alanine there, that fragment F1 should have a mass more than 71.1, right? So that's not the case here. So alanine cannot be there, so it has to be only glycine, the first amino acid. Okay. Now the second fragment, okay, what we are adding an acyl moiety of A2 to the first fragment. So the difference will be 147.2 is the difference. Okay. Now this corresponds to actually the molar mass minus 18 of the second amino acid A2, right? So we know that Ma2 minus 18 is equal to 147.2, where Ma2 is the molar mass of A2. So what happens? Ma2 is 147.2 plus 18, which is 165.2, which is the molar mass of phenylalanine. So A2 is phenylalanine. Okay. A3, same logic. F3 is added to F2. The difference between F3 and F2 is 129.1. You add another 18 to 129.1, you get 147.1, and A3 corresponds to glutamic acid or glutamate. Okay. Similarly, F4, it's a difference of 101.1 from F3. Okay, you add 18 to 101.1, you get 119.1, which corresponds to threonine. Okay, similarly, Fy, okay, is 131.3 more heavier than F4. Okay, you add 18 to 131.3 and you get 149.3, which corresponds to methionine. So the final sequence of this pentapeptide is glycine, starting from the N terminal: glycine, phenylalanine, glutamate, threonine, and methionine. And methionine. Okay, so all right. So the actual calculation of its net charge at pH 11 as well as its isoelectric point will be discussed in the subsequent video, of the link of which I will leave in the comment section. Okay, all right. Thank you very much and have a nice day. Bye.